Hey everybody, this is David coming to you from the Proof of Pod editing studio. This interview with Noah Healy has been cut into three parts for your viewing pleasure. The first part is about blockchain technology and some of the vulnerabilities inherent in the system. Please enjoy. Greetings to everyone who's ever wondered, why are they trying to put that on a blockchain? This is Proof of Pod, episode 17. My guest today is Noah Healy. Are you there, Noah?
I am. I'm looking forward to
Fan
this.
Fantastic. So you and I met for the first time a few days ago. We had a wide-ranging conversation, and we decided for the show, to focus it on non-cryptocurrency blockchain applications.
That's correct. Yes.
All right, fantastic. So let's just start with what kind of the core or the mainstream cryptocurrency is. You've got of cryptocurrency today is, right. You've got the ones that want to be currency, like Bitcoin. You've got kind of the utility coins like Ethereum, XRP, Sol, of course, Solana. And you've got meme coins, which aren't really trying to be a currency. They are kind of more about the fun, the collectability a bit. And then you've got, of course, NFTs, which are more about the collectability. And I think that's pretty much the crypto space at this point.
That's the crypto space that's focused in the financial sector these days.
Yeah.
Yes.
Okay, great. So we're going to try and talk about stuff that's not any of that.
Correct. Yes.
Fantastic, fantastic. This will be a nice change of pace from what we normally talk about and very important stuff. Okay, so why don't you introduce yourself real quick? What's your profession? What's your area of expertise? Or
Yeah. Okay.
areas?
So yeah, my name is Noah Healy. I am a professional algorithm developer and an expert on computational mathematics. I've been working for about a decade now on a project to upgrade how efficient markets are, and I'm widely read and widely practiced across various programming, data science, and other computational math related disciplines.
You're coming to us from a college town, right?
That's right. Yeah. Born and raised in Charlottesville, Virginia.
Oh
This
yeah,
is also the hometown of two U.S. presidents, Jefferson and Monroe.
nice.
Their homes are both within walking distance of my home. And yeah, UVA is here. And that's actually, I started going to UVA while I was still a junior in high school. And that's where I graduated.
Fantastic. All right, let's get right into it. What is a blockchain?
So a blockchain is the sort of next recursive level beyond the kind of standard non-repudiation handshake protocol in cryptography space. So cryptography has been an exciting area of mathematics and signaling for almost as long as the mathematization of communication existed, and it's uh, there's a quote about how it's basically about Alice and Bob who are trying to figure out how to overthrow the government, but they don't trust each other, and and one of the big breakthroughs that allows for you to do things like online banking is the ability to create these asymmetric cryptography tricks where it would be possible to establish that somebody was who they said that they were online. And so that concept is called non-repudiation. And uh, when you buy something off of Amazon, or go take a look at your bank, or even sign in to many websites that you might be on, like, just members of, that process is happening. What blockchains do is they take the next level of that and create a mechanism by which many, many parties can participate in the common non-reputability of common knowledge among themselves. So the phrase that I've used, and this is a little hard to swallow, but it's every part's necessary. Everyone agrees that everybody agrees that what everybody agreed to is what everybody agreed to. And it's easy on its face for everybody to agree to something,
Huh.
because what if each person has a different view of what that something is? No problems, right? Until
Mhm.
the time comes to actually act on it. And so what a blockchain is doing is establishing, using these same cryptography tools, a set of information that the participants can all be assured that all of the participants can't repudiate and say, no, no, I didn't mean that, or you made a mistake, or whatever. Uh, and so, whereas we've been using the sort of one-to-one version for around, call it like a third to half a century at this point, um, blockchain moves that up from one-to-one relationships to group relationships.
Right. Okay, so to break down some of those things a little bit, one thing that I now that I since I've become a little more into cryptography, around 2014 or so, there are some everyday things that just seem kind of like, why aren't we using cryptography for this, right? Like recently we had an advance basically in the credit card space where it used to be like a long time ago they would actually make a carbon copy of your credit card, right? But even up until just a few years ago, the merchant would have like all your credit card information, and that's how they would prove that you were there using your credit card. So they had an advance recently where they have like the smart chip in your credit card, so that there's the merchant can't just reuse your credit card and somewhere else instantly right after you leave the store, right?
Yeah, cryptography is has all kinds of unintuitive and almost unimaginable possibilities. And we, as you say, we really have not integrated those systems into our day-to-day world. There's there's a there's a thing that has come up for around me a time or two before. Back in, I think, 2002, 2003, I read a paper where some fairly well-known cryptographers had developed a voting system that was cryptographically sound. Uh, and I have been asked about sort of improving voting systems a couple of times in the intervening decades. Sometimes, it becomes something that people are interested in talking about. And I always point back to this paper. And at one point, I almost might have been getting a consulting gig for somebody who was trying to put together a foundation. And after I pointed out this paper, I never heard from them again. But
Mhm.
uh, they worked out that you could print ballots on this sort of acetate or clear plastic on both sides, so that the ballot would only have its sort of final information uh, if it was glued together sheet to sheet. So you would vote, a machine would print off a ballot that would be fully, you know, confirmable by you, because you could look through it and see that it was what you wanted. And then you could rip it in half, front to back, and get two halves, one of which had no personal information on it, and one of which had no voting information on it, except um, because there's tricks that you can do with, again, hashing, cryptography, and other things. Your receipt would have a 50-50 chance of determining whether or not your vote wound up in the final tally. So in addition to tallying, there was also this ongoing accumulative hash value. Uh, and I'd have to go look at the paper again, because I might have some details wrong. It's been literally over a decade since I read it. But I can kind of understand that, yes, that is possible, and if you did it the right way, you could set that up so that effectively you you would be able to have, it, if the votes were tampered with, 10 random human beings would have a 99.9% chance of determining that the votes weren't properly accounted for, essentially. And so yeah, that would be highly impressive, but we never hear about that.
Yeah, that is one of the uses that's kind of been. I hadn't heard about this sheet of paper thing, but like using digital cryptography, a lot of people have suggested that you could make elections more verifiably fair with cryptography. But blockchains specifically, well, I guess one of the key features of one-way cryptography is that it's chaotic. I think the if you change the initial uh, phrase or document that you're encrypting just a tiny bit, the end result is completely different, right?
Yeah. The goal of a good crypto system is that every 1 bit change in the input should change roughly half of the bits in the output. Um, and so what this leads to is a situation where it's very hard to unscramble the egg
Right.
because it you can't kind of work out how to do that.
So when a block is printed into the blockchain, the next block must hash the contents of that block, right? And uh, you know, there's no way to predict, like even if you could predict 99% of the characters that are going into that block, you still wouldn't be able to hash it properly without that final 1%. And so the chaos or the unpredictability of the one-way cryptography means that once something has gone through this one-way cryptography, you can't like unscramble it like you were saying. You can prove, therefore, that this was done in the blockchain terms, like in order sequentially, so that each block builds upon another, and there's cryptographic proof that it has not been tampered with.
Broadly speaking, that is correct. Yes. Of course, in if the only kind of one-way cryptography that existed was just this hashing that blockchains are based around, there would be limited utility. So some of these things can be reversed if you have access to a key, and
Right,
then that provides the security.
right,
But the other problem to bear in mind is that while we have algorithms for which no public efficient solution exists. We do not have algorithms which we have proofs that no efficient counter computation can exist. And so there's a long history of these candidate hashes being proposed, being used, eventually falling apart as somebody figures out what the problem was, and then you have to move on to new candidate hashes.
so that's one of the possible issues with any particular um, blockchain is that the hashing algorithm that is based upon could be flawed in some way that will allow people to kind of take a shortcut or cheat it and do something that should be computationally very expensive, but in a cheap way.
Yeah, and that's one of the fundamental goals of cryptography itself is to try to figure out how to solve those problems. So unless you are constantly trying to break these hashes, you can't be assured that somebody else hasn't broken them.
So, did Satoshi Nakamoto invent blockchain?
I think that's perfectly fair. Yeah. Uh, I'm not aware of anything that kind of solves the recursive stability problem before him. Like I said, there's a lot of pieces that had been in the air for decades. And Satoshi was actively involved in online, highly anonymous discussion groups where many people were, in fact, talking about what properties would be necessary, but yeah, Satoshi's white paper and blockchain 1.0 is the actual implementation.
What are the desirable traits of a blockchain?
Well, the big one is that non-reputability I was talking about before.
Yeah.
Um, but There are other potential desirable traits.
So just
Uh,
to link it back to Bitcoin, this is kind of like preventing the double spend, right? You can't,
Correct.
yeah,
Yeah.
you can't
Um,
send your Bitcoin to person A and then send it to person B and say, "Oh, I didn't actually send it to person A," even though you already got the goods and services or whatever from person A.
right. Well, in the case of a hash collapse, things can actually get significantly more serious than that. So what's in people's wallets is what is on chain says is in people's wallets. So if you can write arbitrary chain blocks that meet the mathematical requirements, you could write one that says that your wallet has all of the blocks in them, and just say that everybody gave you their blocks because they felt like it. There was actually Ethereum is a
They're blocks. What do you mean by blocks?
their I'm sorry, their coins
Okay.
are in your wallet. Yeah. Ethereum actually had a fork where there was a bug in an early version, and somebody exploited that bug to write some chain nodes that basically took the billionaires that were backing it and said that they'd given them their money, and the billionaires that were backing it said, "We're gonna everybody's gonna like go back to before this happened. We're gonna drop a patch, and then everybody's gonna use the one that says that we're still rich because that's the only one we're ever gonna use." And everybody did. So
Right. This is the famous Ethereum DAO hack.
yeah.
Okay, so this is a bit of a tangent, but let's go ahead down it real quick. Um, my understanding is that you can't write a Bitcoin block that where you take everybody's Bitcoin because you have to have the signatures of the addresses that are spending the Bitcoin. Just because you're allowed to write a block doesn't mean you can write an arbitrary block.
That's somewhat true, but again, every one of those is a cryptographic protocol of its own. So um, it would be a hard problem to break the block hash and allow you to write arbitrary blocks. It would be a separate hard problem to break any one of those signatures. But since we have no mathematical certainty and every one we've ever had eventually broke, um, it's not beyond imagination that uh, somebody could get extraordinarily lucky and basically break two protocols or three protocols at once and do something like that.
Okay. So you're talking about if somebody breaks the protocol that Bitcoin uses, which is SHA 256.
Yes, yeah. I'm talking about sort of absolute worst case scenarios here, where let's say we discover either that the entire public infrastructure of how we've been developing cryptographic uh, functions for public consumption was corrupted, and somebody had built backdoors into everything, or um, some foundational breakthrough in cryptography occurs that breaks multiple simultaneous protocols that we are currently using, and in either of those cases, you could see something like that occur.
So the non-repudiation is the first uh, positive aspect of a blockchain that you don't.
Yeah, yeah. That's the really big thing that blockchains actually offer.
There's also like the public nature of it, right? As opposed to data which can be stored much more efficiently in some company's server or whatever. A blockchain is exposed so that everybody can see it and verify what's going on.
Yeah, well, that's a two-edged sword, and that gets
Sure. Yeah.
into some of the downsides of blockchain.
Sure.
Um, there is protocol overhead, which is considerable. So if you just have some information that you want to be public and you want sort of non-repudiated, the way that software patches are distributed, where you just, put up a bunch of mirrors and drop some hash sums on them is in general a better approach, um, rather than tracking like where they came from and so on. Just having some institution that is trusted is a huge savings. You can see this the guy, I can't remember his name, but he wrote a book called Bowling Alone, about the value of social trust and the the sort of more efficient ways that you can operate if you can trust your counterparties to behave in ways that are pro-social. And so blockchains are useful in the situations where you cannot trust your counterparties to be pro-social. But if you could, then much more efficient, just in terms of computation, bandwidth, and so on, options become available to you.
That's Robert Putnam.
Yes.
Cool. I'll put a link in there. Okay, so one of the main downsides then we're in agreement is that blockchain is not as efficient as traditional ways of storing and reporting data.
Yeah, yeah. And there is also a privacy issue. Uh, while encrypted data can be placed on the chain, again, that just means that uh, it could eventually be unencrypted. So, data that should be private should stay away from blockchains unless it has some kind of transitory value where you're not going to mind that at some point somebody will be able to read this thing.
So the public nature is, like you said, double-edged sword because there's some things that you don't want to be public.
Yeah, yeah. Things like medical records, privileged conversations with uh, professionals. Those are things that you would probably prefer to go to graves rather than just be sitting around waiting for some nerd to finally solve a math problem.
All right. Does proof of stake change these features at all?
Proof of stake has different consequences to proof of work, and in general, proof of stake systems have lower actual overheads because proof of work systems gain their trust by how many clock cycles that you have to throw at things. Um, but it mostly keeps those double-edged swords going, and proof of stake systems also aren't as efficient as high trust solutions if those are available.
In other words, even if you have a proof of stake blockchain, it might be 10 times more efficient as a proof of work blockchain, but it still might be 100 times less efficient than a private database.
Uh, yeah, yeah. That second number could be radically higher than that.
Yeah, sure. Thanks for watching part one of this three-part interview. Please check out part two, where we talk about the non-cryptocurrency uses of blockchain technology.